I'd also like to mention what we also do in our other backyard north of here. The North Plains Research Field is owned by the North Plains Groundwater Conservation District, and Agrilife Research leases it in a partnership for research to develop feasible crop production technologies to help producers going forward. This is what the NPRF looks like today. We now have 2 research center pivots, an old linear system, and 59 border plots, along with some dry land and irrigated fields. Part of my philosophy at the research field is that we need a mix of both basic and applied studies. Why? Because basics needed for proof of concept, documented by referee journal articles. Yeah, I said referee journal articles. Basic type research is also effectively a new knowledge proving ground. Applied, it's more like concept demonstration and can be helpful in the role of producer adoption. It can also be a showcase outlet for commodity support dollars and demonstration work. But we can't do it all because of agency priorities, limited budgets, and resource constraints. And our main focus is and still has been research, and we in Agrilife get reminded of that regularly by our bosses, particularly around performance evaluations. We do a lot of small plot research at the research field, and most of it is quite expensive. Projects that the research field has studied in the past was the economics of water use, but the majority focus today is on corn due to the percentage Harold mentioned earlier. Cotton was also researched before the industry was reinvented earlier this decade. We had years of production data, and it was published in refereed articles long before the gin came along. This was even before 2,4-D bands were in place, so we had data on tell you which one of those was most resistant to 2,4-D impacts. The NPRF averages about 20 studies a year, but many may ask, what about the research outputs? Well, again, our best output are the refereed journal articles. If you're a producer, do you really care about those? Most growers don't and won't, but maybe they should. But why should they? Our refereed journal articles are evaluated by the scientific community. They have to be based on sound science, and they have to add up, and they have to make sense. We don't sell anything, we're unbiased, and it has to stand the test of time. So if there is a big difference and we can't explain it, then we've got to figure out what makes it different and why. We've got to understand before we can be understood. Results must be proven and explainable and add up. So should a producer now rush out and request a bunch of refereed journal articles for production purposes? Of course not. That's what we got the extension service for. Alternative crops, I already mentioned that. Why the cotton, as Harold mentioned? Because you can get the same net profit on 40 to 50% of the water you can with corn. Cotton's here to stay. It's going to be part of the water plan. Other crops we've looked at, soybeans, sunflowers, peanuts, potatoes. Did you know we grow potatoes up at the research field? On hard clay soils. Guar, canola, forages, and grasses. We do this stuff on small plots so people don't lose money on big plots. Interest of time, I'm going to skip that one. We did a 12-200. I'm surprised to see that Harold called it 12-200 because they call theirs 212. But then again, I heard him say this. So anyway, our study's different than theirs because what we're trying to do is it's a science-based study. And what does science-based mean? More data? Yes, it means more data. We're trying to explain why and how things happen. And for instance, during the production world, we want to understand what makes those mechanics of that system work. So we take a lot more data, and the preliminary report's been compiled. But we also recognize that the 12-200 is a point study. And that's of less interest to us generally in research because we want the crop production function. So this is just part of a demonstration point study at the research field, but we've learned some interesting things here, even using the 3 commercial varieties. They're not created equal, and they're not all the same. Some surprising news. I recently just got back from Puerto Rico, what I consider to be one of the best corn breeders I know of in the state of Texas, maybe in the nation. It's One Way U out of Lubbock. And I got through looking at the winter nursery varieties, and it's amazing what these guys can come up with in terms of the genetics. They don't know what's happening on the rest of it, but they're world class in the genetics. And he told me that there's 250 races. That's what they call them. They don't call them lines or germplasm. They call them races. I'm an engineer, so they have to translate for me. He said there's about 250 races out there in the genetics pool. 90% of all the commercial hybrids in the United States today use 2. My question is, what do you know about the other 248? And they said, little. So let's keep this in perspective. How much do we really know in the genetics world about what we can do? That's a scary thought in the engineering perspective, I assure you. Okay. Dr. Hsu actually conducts about somewhere on the order of about 5,200 germplasm cross experimental hybrids test up at the research field every year. And we don't do that under one scenario or one point study. We've modified some center pivots up in our area where we're doing 175, 65, and 50% ET, and we propagate those same varieties so where we can test under the same control strategy, same irrigation management scheme, the performance of these different lines, races, and germplasm pools. And it is scary of what they can accomplish doing that when everybody works together. It's been so successful in the corn war, now the wheat boys went into it, and I had a wheat breeder who put it in under another part of the sprinkler, and he said, I planted a few plots. And 2 days ago, I found out he planted over 3,000 few plots. So I'd hate to know what he meant when he said, I'm going to plant a lot of plots. It's really scary. He's also done some corn silage work because of the dairy industry. And the surprising thing about this is all the corn work is classical breeding. It is not transgenic. And the reductions are really, really good. We've got some preliminary data that shows the yields can be sustained using 25% less water than we're currently used to using classical breeding varieties that are on the horizon. That's got implications that we can continue to produce corns with reduced water. Now, there's a lot of argument in the agronomic world, are we really making gains or are we really not making gains? And the argument continues and ravages on. But I want you to look at this slide here because this is what we're doing and why it's important, why we don't have all the answers. If this is our typical production curve, that number is wrong, by the way. That's closer to about 10.5. And that's the amount of water it takes before you get one kernel of seed. All the research that's been done in the past has all been in this area right here. It's 12,200, and all the studies we're going forward is starting to want to know what's happening here. Folks, we don't know. And what's surprising is it seems nobody knows either. I asked the industry people in their R&D programs why they don't develop this, and they go, it's too costly. We were hoping y'all people in government would do that. You know, I said, what makes you think it's any cheaper for us? And what amazes me is it's this part of this curve. If you don't know this, how can you determine what your net returns on your bag of seed is going to be? And what you find out is they're guessing and they don't know. That's why they don't know how to price a bag of seed. Now, that's really scary if I was running a major corporation. But I will tell you this, if we're taking this value right here, we're pushing these curves this way on this graph. And our gains in yield are also pushing these curves higher and higher. If we're not changing these base points, what's happening to the slope of these curves? They're getting more and more steeper. What does that mean? That means that the irrigation management is becoming ever more critical. You mess up even one irrigation, you're going to pay that cost. This is why I said we're interested in crop production function data at multi-level irrigation management schemes. This is what's happening not only on the research site, it's what's happening in the R&D on the industrial sites. A few notes. Research is neither free nor efficient generally. By design, we want to include non-optimal and control plots in our research. That's why we need to keep studying maximum potentials in research. It reduced it by compared to what? If we don't know what the maximum potential is and if that number's changing, how do we know what the reduction is? We don't. Today's research cost. The general perception is state supplies 100% of our research cost basis. No. In the days when I started, the state supplied 75%. Today, 25% of our research budgets are funded by the state. We're expected to find the other 3/4 of it to operate. If you didn't know that, then our administrators haven't been telling you, or you haven't been listening, I don't know which. But anyway, this is a big misconception that we have the resources to conduct all of this. We don't. We have to chase it. Negative outcomes are also valuable and publishable. Why? Because most people discount them, but we need to document those to keep others from retrying or reinventing the same wheels and spending some more of those research dollars. The other thing is the R&D costs are directly proportional to the facilities and the personnel we're able to get. One gets what they pay for. Industry knows that better than we do in the government or the public side of it. They put about 95% of the R&D dollars into investigation now. The public sector puts in about 5%. We also got to looking at some state ag economic outputs, and this is really scary. I did a presentation last year, and it floored me when we pulled the numbers. These are not my numbers. These come out of the Bureau of Economic Analysis out of Austin. So if you don't like the numbers, get them to change them. The GDP for Texas for 2008 was about $1.2 trillion. Ag accounts for about $6 billion of that GDP. That number seems low to me. So when you look at it, what's ag worth in the state? When you look at it from an Austin perspective, 0.5%. I did this in May. It was 0.8%. But the Panhandle accounts for 27% of the state's ag output. This is not going to get any better, folks. What it means is ag could go away, and according to the state's GDP, the average person wouldn't even notice this. Rate, our estimated return value. We've calculated a bunch of numbers, and about the best numbers I can come up with, depending on which way you calculate it. It's we get a return of about 10 and 25 to 1 generally, so you can pick any value. I went over and asked my good friend, Dr. Steve Amison. He's a Regents economist over at Extension Service. I like Steve a lot, and he said the answer's 5. I don't care what the question was. So, you know, Steve's answer to all my questions is usually the answer's 5. So I doubled it, and we'll call that good. Where are we going to go from here? We're going to continue to make advances in genetics, irrigation management. We're going to production gains. But the new stuff that we're going to see more of the remote sensing. We're going to see more electronics. We're going to see more integrated tools and applications. And we're going to see some new technologies in the seed bags. But that's not going to come free, because it's going to have, for those promises in those seed bags to be realized, you're going to have some ancillary technologies to accommodate them. Last thought. So what about the importance of ag research in the real water concern? You think folks got mad when the gas pumps went dry in '73? What do you think they're going to do when the water faucets go dry? I've seen it twice in the state of Texas. You don't want to be there. Thank you.